Hey everyone, welcome to this explainer. Today, we're jumping right into some absolute magic happening right under our noses, in gardens and farms every single day. We often look at flowers and see nothing but a pretty plant, but there is incredible science, complex anatomy, and a desperate biological drive happening within those delicate petals.
Here is the roadmap for how we'll uncover the secrets of plant reproduction today. 1. More than just beautiful. 2. Anatomy of a flower. 3. The pollination process. And 4. From flower to food. Let's get right into it.
Section 1. More than just beautiful, the hidden purpose of flowers. So our source material brings up this great story about a student named Aqua. She was in her school garden, carefully looking at a hibiscus flower with her teacher, noticing the bright colors and the long structures right in the center. It's exactly the kind of hands-on curiosity we're going to channel today.
Looking at a hibiscus like that naturally brings up a really guiding question. Why do many flowers have such bright colors and sweet scents? It's so easy to fall into the trap of thinking flowers exist purely for our aesthetic pleasure, right? Just to look nice in a vase on the kitchen counter. But biologically speaking, the plant is spending a massive amount of its energy producing those colors and smells. So why?
Well, the reality is, a flower isn't just a pretty decoration. It's actually a highly efficient biological manufacturing plant. It is the reproductive part of many plants. Literally every vibrant hue, every sweet smell, and every structural curve exists for one singular, absolutely critical purpose: ensuring the survival and reproduction of the plant.
Section 2. Anatomy of a flower, the outside-in tour. Our first stop is on the very outside with the sepals. These are those small, green leaf-like parts you find right at the base of the flower. You can think of the sepals as the plant's essential security guards. Before the flower even opens up, when it's just a highly vulnerable developing bud, the sepals tightly enclose it to keep it safe from harsh weather and hungry pests.
Moving one layer inward, we find the petals. Now, this is obviously the part we usually notice first, but in the business of plant reproduction, petals act as the brilliant marketing department. Their bright, flashy colors and sweet scents are specifically engineered to act like giant billboards, luring in crucial insect visitors, like bees and butterflies, that the plant desperately needs. All right, now we go even deeper, past the marketing department and into the long parts inside the flower, to find the actual factory floor. This is the stamen. The stamen is the male reproductive part of the flower. They often look like long stalks with little powdery tops, and the stamen's entire job is to produce pollen. And pollen is one half of the core reproductive equation. Finally, sitting at the absolute center of our botanical engine, we have the pistil. The pistil is the female counterpart to the stamen. Its vital job is to receive the pollen that the stamen produces. Once it successfully catches that pollen, the pistil gets to work acting like an incubator, helping in the formation of seeds. So let's quickly review the workforce we've just uncovered. Every distinct part of this system has a highly specialized job to keep the plant alive. Sepals protect the bud, petals attract the insects, stamens produce the pollen, and the pistil receives that pollen and forms the seeds. It is a total masterclass in biological collaboration. Before we set this whole system in motion, let's make sure we clearly contrast these two central reproductive engines, stamen versus pistil. Remember, the stamen is the male part, and it focuses entirely on producing those microscopic pollen grains. The pistil is the female part, and it's structurally designed to catch that pollen and use it to form seeds. Two very different jobs, but completely reliant on one another.
Section 3. The pollination process, putting the pieces in motion.
Let's walk through this brilliant step-by-step biological reaction to see exactly how the plant achieves its ultimate goal of reproduction. Step 1. The marketing works. Insects are attracted by those colorful petals. Step 2. As the insect brushes around looking for nectar, pollen physically moves from the stamen to the pistil. Step 3. As a direct result of that microscopic transfer, the flowers begin to alter and actually develop into fruits with seeds safely hidden inside.
Our source text distills this down to one beautifully simple sentence. When pollen moves from the stamen to the pistil, pollination can take place. I really want to emphasize this exact magical moment of transfer. That physical movement of a tiny grain of pollen from point A to point B, that is the entire reason the flower's incredibly complex structure exists in the first place.
Section 4. From flower to food, the agricultural stakes.
Now, many food crops produce flowers before fruits and seeds are formed. This is a foundational rule of farming. Without that delicate flowering stage, without the sepals protecting the bud, the petals attracting the bees, and the stamen transferring pollen to the pistil, the crops we rely on simply wouldn't be able to yield the food we eat.
And we aren't just talking about rare botanical specimens in a greenhouse here, we are talking about our dinner plates. Crops that rely directly on this floral reproduction process include things like tomatoes, mangoes, oranges, and beans. Grounding this science in a delicious reality reveals a very simple truth. No flowers, no mangoes.
Which leads us to the end of our explainer, and I want to leave you with this really provocative thought to chew on. What might happen if insects do not visit flowers? If the marketing department fails, or if the bees and butterflies just vanish, the pollen doesn't move, the seeds don't form, the fruit doesn't grow. It really challenges you to realize just how incredibly fragile our entire agricultural ecosystem truly is. Next time you see a flower, you'll know exactly the complex, vital work happening inside it. Thank you so much for joining me, and keep observing the world around you.